determinant is a real number associated with a square matrix. So a determinant is not a matrix, it is just a number. It has two notations that you may see. You might recognize this one from like looking in your calculator when you go over to the math menu within the matrix menu. The top one is DET, so a determinant of A. So you can check determinants in your calculators, but I'll be asking you to do 2 by 2s and 3 by 3s by hand. Okay, so they're both pretty reasonable. There is a second notation that you might see. It looks like absolute values, okay? But it's important here, this is not an absolute value. This is determinant A. So it's read the same way. You can use either notation that you prefer. Be familiar with all notations. I'm going to ask that everybody take out their earbuds, earphones, etc. I can never tell if you're listening to music or not. All right. Calculating a 2 by 2 determinant. So here's our matrix A. Okay. I'm going to use some notations. The determinant of A, you can show the entries within the determinant by using that thing that looks like the absolute values. So remember, if you see something that looks like a matrix, but it doesn't have the brackets, it has the straight vertical lines, it's actually asking you to calculate a determinant. So it's asking you something different than showing you a matrix. And you calculate your determinant like this. Product of the first diagonal going down, that's AD, minus product of the diagonal going up from left to right, CB or BC. Look familiar? As last night's denominator for your inverse, 1 over AD minus BC. So we could also change the inverse formula or definition that we got yesterday for 2 by 2 matrices to read 1 over the determinant of A equal or times all that stuff where we switch A and D, change the signs of B and C. Can you find the determinants of the matrices below with your groups and double check your answers? So it's just a simple calculation. Your answer is a number. No calculators. You're doing this by hand. You should be able to do it by hand. It's simple. Diagonal, subtract. Okay, the determinant of A, if you want to write it out, you can write something like this. That's going to be negative 1 minus 6. So did you get a negative 7? Okay. I could do something like, I don't have to show all that work every time. I could say the determinant of B over here in the second matrix is 10 minus, be real careful here, 0 times negative 4 is 0, not negative 4. It's easy to like convince ourselves otherwise when we're doing this multiplication. So determinant of B is 10. And on the last one, let's do DETC, determinant C is 12 minus 12, which is 0. So determinants can be positive, they could be negative, they could be 0. If I ask you to think about those 3 square matrices, which one does not have a inverse? C, right? That would be that whole thing yesterday where 1 over AD minus BC, 1 over 0, that's undefined. There is no inverse for that square matrix, but the other square matrices would have an inverse. Okay, that's 2 by 2. Let's do 3 by 3. Now, 3 by 3 isn't necessarily like a lot harder. It's just that it's more work. It's not just 2 diagonals, because you got all these rows and columns. So, I'm going to rewrite this for my 3 by 3. I'm going to say the determinant of A is equal to, and then I'm going to draw my determinant bars. I'm going to put in A, B, C, D, E, F, G, H, I. Okay. So here's the thing to remember about 3 by 3 determinants. It's more than just an X, like a diagonal going down and a diagonal going up. Because think about that. If you do that X, you're leaving out all of the letters like B, D, F, H. They don't have anything to do with the determinant. So that seems like a little bit funny. Shouldn't all the entries in the square matrix have something to do with the determinant? So what we're actually going to do is we're going to do 3 diagonals going down from left to right, 3 diagonals going up from left to right, okay? And I'm going to make this a lot easier here in a second, but like the first diagonal is really easy, right? AEI. The second diagonal is going to start with B, and it's going to be BF. But could you imagine if this was like 3-dimensional space? I would wrap around my matrix and I would pick up the G. And the third diagonal is going to start with the C, wrap around the matrix, and it's going to pick up the D and the H. That's the rest of its diagonal. Okay. But there's a real easy way to do this without like having to like think about wrapping around. You just copy the first 2 columns. You don't really need the third column because your diagonal isn't going to reach that far. So you only have to copy the first 2 columns. And then you see you're going to get your AEI, your BFG, the one that you would wrap around to, and your CDH, C wrap around DH. So here's how we'll write our determinant. Take all 3 of those diagonals, and you're going to add them up. AEI plus BFG plus CDH. And really, like, those are all going to be numbers, right? So you're just, like, adding up 3 numbers, and then you get a single number. Subtract from that, just like we did before, we're subtracting the products of diagonals. But now we do all the diagonals going up from left to right. So I go to this bottom corner, I'm going to get my GEC, HFA, IDB. Okay, and I'm going to add up all 3 of those. So I'm going to put that in parentheses. GEC plus HFA plus IDB. So that would be like a fair definition of how you're going to create the numbers that go into the 3 by 3 determinant. But it'll be a lot easier like when we do our example because like you'll just write down what the numbers are and then you add them up and you get a single number. So it should really be like a number minus a number. You got a question? Okay, but no question? All right, let's do the determinant. For 3 by 3. Down below. Copy the first 2 columns. 3, 3, negative 1. 4, 5, 4. And I like to do my diagonals. I like to get my work pretty organized so that like if I make a small multiplication error, I can find it. So I do this. 3, 1, 5, or sorry, 3, 5, 1 is going to multiply to be 15, right? So I just write that at the bottom of the diagonal. And then I'm going to put a plus sign, and I'm going to do my next diagonal. 4, 0, negative 1 is going to multiply to be 0. And then I'm going to multiply on the next diagonal, negative 2, 3, 4. That's plus negative 24 or minus 24. So I like to just keep track at the top and the bottom of all my diagonals. That way if you're like, I didn't get that number, I can read to you what my diagonals were. Negative or 15, 0, negative 24. And you could be like, oh, for 0 I said it was negative 4. Right? And we'll know exactly where you made your mistake. But if you don't write that stuff down, it gets really hard to like help you. Okay? You just have to restart all over if we don't know what you did wrong. Let's see, that totals up to be negative 9, am I right? 15 minus 24. And then do the diagonals going up. That's a positive 10 plus 0 plus 12. So minus 22. Remember that you're subtracting the sums of the diagonals. So that was a positive 22 as a sum, but I'm subtracting 22 in the formula. And so my determinant is negative 31. Okay, any questions on where I got my numbers, why I did what I did? Okay, again, I like to do it, write out my work at the tops and bottoms of the diagonals, add those things up so I only have 2 numbers to work with right here instead of the parentheses and adding everything. And then I'm just getting a single number answer. So negative 31 is that special determinant real number value that goes with that square matrix. And we're going to use that on Thursday to solve systems. Okay, now on the back side of this page, there's just a note up at the top. Okay, no calculator. You should be able to do 2x2s and 3x3s. Anything beyond a 3x3, you would use your calculator, go plug in your square matrix, call up the determinant, call up that matrix, and hit enter. I'll also say this, like for real world situations.
To go to the main gym for pictures. National Honor Society, Quiz Bowl, Robotics, Science Club, and Senior Class Officers. Again, that's National Honor Society, Quiz Bowl, Robotics, Science Club, and Senior Class Officers.
For real world situations, like if you're really using a matrix as like a way to organize data, like likely your data is full of really big numbers, decimals, like not nice things. So then, of course, I'd be using a program or a calculator to do determinants with those types of numbers. So that box also says that information. Okay, the next part that we want to talk about are uses of a determinant. And just so you're aware, all 3 of these are actually from section 8.5. So like when I give you time at the end of class today, when you're working on the homework for tonight, it is what we just did. It is not very hard. Okay? So you'll be able to get like a nice chunk of it done here in class. But because I don't want Thursday to be super heavy right before a quiz, I'm going to do a little bit of 8.5. Then we only have one thing to cover on Thursday. And tomorrow's going to be a day we're going to do like an activity or review. You'll have a review worksheet. So that'd be a nice moment for everybody to be like, okay, how am I doing on all this row echelon, inverse matrix, determinant kind of stuff. Okay. You have many ways to do areas of triangles. If I gave you 3 points in the coordinate plane, can you imagine how 3 points in a coordinate plane could form a triangle? Just like wherever they are. Okay, 3 points in the coordinate plane, and you want to find the area of that triangle. Okay, matrices can do area of a triangle for you. This is the formula. The area of the triangle equals plus or minus 1/2 times the determinant that has the following entries. Your first point as a row with 1 at the end. Your second point as a row with 1 at the end. And your third, that's an X, point as a row with 1 at the end. So you need a square matrix in order to be able to do a determinant. You have 3 points, so you're going to have 3 rows. So we fill in the final column with 1. Now, read very carefully this final statement. Where plus or minus indicates the appropriate sign that should be chosen to yield a positive area. Think back to geometry. If you were describing an area of a triangle or length of a side, don't those values have to be positive? So your determinant might come out to be negative, but then you would multiply it by -1/2 and you get a positive area. If your determinant comes out to be positive, then you'll multiply it by a +1/2 and you'll still get a positive area. So you're not actually multiplying it by plus or minus 1/2, like both. You're choosing the appropriate value. What's the one thing your area or your determinant shouldn't come out to be if it's really a triangle? 0. You shouldn't get a 0 area because then, like, what kind of triangle do you really even have, right? If there's no area in it. Okay, let's do it. Area equals plus or minus 1/2 times the determinant 0, 0, 1, 4, 1, 1, 2, 5, 1. I just plugged in my points in each row. Remember that final column is going to be all ones. No, you can do this by hand. And this one's going to be super easy because look at all those entries of 0. 0 is easy to multiply with. 0 plus 0 plus 20. So this is plus or minus 1/2 times 20 minus 2 plus 0 plus 0. 2. I'm multiplying on the diagonals, right? And then I'm adding up the product of those diagonals. So when I did my green ones, 2 times 1 times 1 is 2. 5 times 1 times 0 is 0. 1 times 4 times 0 is 0. That's how I'm getting those numbers. And then I add them up. Okay, well, what's my determinant? 18, positive 18, right? So when I'm actually doing my area, now I can choose. Will I multiply by positive 1/2 or negative 1/2? Positive. So 9 units squared. Now there is a proof for that where you like draw the picture, basically like a coordinate plane proof. It's more work than I really want to spend time in class doing for that, but if you want to like Google it or look it up, you can.
Where did you use the 4 in the first column? Did you use that?
No. It actually gets used. See, Lexi, right over here, I recopied it. It does get used. I'm copying those columns, so I'm like wrapping around. So all the numbers are getting used. But you just need the 3 diagonals going down, and then the 3 diagonals going up. Okay, any questions? Okay, now, what did we say was what couldn't be true about the determinant for this one? Couldn't be 0. Okay, what if the area of a triangle was 0? Aren't we just like on this one that I have on the side, like how do you make the area smaller? Do you just like drag this vertex in? Right, and it gets smaller and smaller and smaller, and then when does the area of the triangle actually get to 0? When it hits the base, when it's on the line. So that leads us into the next use of a determinant. You can tell if 3 points are collinear, because if they're on the same line, then there is no triangle between them, so their determinant is 0. So 3 points are collinear if and only if this determinant that we use to find area of a triangle won't actually give us any area. It's equal to 0. Notice I'm not putting the plus or minus 1/2 there because I'm not really even checking for like what is the area. I'm just seeing like the only way that isn't a triangle is if the determinant is 0, because then you're saying you have no area. So then you have 3 points on the same line. Okay, so if you want to make a side note down here, if the determinant is 0. Then the points are collinear. That's basically like, in my own words, what that's saying. Then they lie on the same lines. Okay, so all you have to do if you want to check if 3 points are on the same line, plug them in, do determinant. See if you get 0 or not. So we'll check these 3 points. -2, 4, 1. 3, 1, 1. 6, -4, 1. Same setup. Last column is all ones. -2, 3, 6. 4, 1, -4. Calculate my determinant. So going down, -2 times 1 times 1 is -2. 4 times 1 times 6 is 24. 1 times 3 times -4 is -12. That's 24 minus 14, so 10. Okay, now I'm going to do the diagonals going up. 6 times 1 times 1 is 6. -4 times 1 times -2 is 8 positive. 1 times 3 times 4 is 12. Add those all up, that's 26. So 10 minus 26 is -16. That's not equal to 0. These are not collinear. The only way I can say collinear is if they're on the same line, if their determinant is 0. Questions, concerns? Okay, last one. This last one is going to build off of collinear, right? We're checking to see if 3 points are on a line. The last slide is going to ask you to write the equation of a line. Now, to write an equation of a line, and this goes all the way back to like algebra 1, you don't need 3 points for a line. You only need 2 points, right? So like, I'm giving you 2 points, x sub 1, y sub 1, x sub 2, y sub 2. All the other points, okay, so like on the sideboard I'm going to draw right here, I got an x sub 1, y sub 1, and I've got an x sub 2 and a y sub 2, and those are going to be like numbers, right? And you can imagine there's a line that connects those points. Well, we want to kind of like set up the same thing where we did with collinear, but we need a third point. The third point that we're going to put into our determinant is going to represent every single point on this line. There are infinitely many, right? All the other points on the line, when you're writing an equation of a line, they are some x and y, where x and y vary. Right? So if your equation of a line is like y equals 2x plus 3, you can start making a table of values and there's just like a ton of numbers, right? A ton of points. Okay? So we're going to treat our third point as this thing that changes. If you don't know what it is, then you put it in as x and y. So to write the equation of a line that passes through 2 points, I'm going to make my first line regular x, regular y, and 1. They are all the points on the line. They vary. The other 2 points are the points that I know. X sub 1, y sub 1, and x sub 2, y sub 2. So I'll be plugging in numbers for these bottom 2 rows, but in this first row, I will leave it as x and y. And in order for those 3 points to all be on this line, I know that the determinant has to equal 0. We just said that. In order for them to be on the same line, collinear, the determinant must equal 0. So whatever we get when we do the determinant, we set it equal to 0, that's going to help us make our equation of our line. So let's write the equation of a line that passes through these 2 points. X, y, 1, negative 3, negative 1, 1, 3, 6, 1. So again, this x and y represents all the points on the line, wherever I want my x to be. Okay, so I leave it unknown, x and y. And I'm going to put over here an equals 0, but I'm going to leave space so I can do my determinant, so I don't have to rewrite it. Now I copy my first 2 columns. And I do my determinant. Determinant's going to work out slightly different here because not everything is going to turn out to be a number. So on the first diagonal going down, x times negative 1 times 1, that's negative x. And then y times 1 times 3. So that's a plus 3y. This is Miss Cronky. Sure. Margaret, you're leaving. Head to the front office. 1 times negative 3 times 6 is negative 18. Okay, but x, y, and 18, those are not like terms, right? So like that's as good as the sum of the diagonals gets. So in my determinant, I'm saying like my first set is negative x plus 3y minus 18. And now I'm going to subtract the other diagonals. Don't forget about your quiz corrections. 3 times negative 1 times 1 is negative 3. 6 times 1 times x is 6x. And 1 times negative 3 times y is negative 3y. So I'm subtracting all of those. I'm going to protect them by parentheses. And now I can go through, I'm going to just go ahead and I'm going to change this minus to a plus and just change all the signs in the second set. Okay, so this is plus, it'll be a positive 3, a negative 6x, and a plus 3y. And then I'm just combining my terms. So what would that be? Negative 7x plus 6y. And is that minus 15 equals 0? Okay, that is an equation of a line. It's probably not the equations that you're most familiar with, right? We really don't usually write them equal to 0. So if you wanted to change it into a form you're more familiar with, a simple fix would just be add 15. Right? So we could say this is negative 7x plus 6y equals 15. So is this one. This one is ax plus by equals c. You remember doing that with like linear programming, like what's the x-intercept, what's the y-intercept? So that would be easy for us to graph then. Okay. And if you wanted to, I mean, you could solve for it in slope-intercept form, couldn't you? Okay, so if you wanted to solve for y, you could
At this time,
add
we need the
7x.
following groups to go to the main gym for pictures. Science Club, Spanish Club, STEM Academy, and Student Council. And also Skills USA. Again, that's Science Club, Skills USA, Spanish Club.
Don't forget about your quiz corrections for tomorrow. In case I forget to say it when you come back. And so is this. This is y equals mx plus b, right? Now, I'll accept any one of those as your final answer for the equation of a line. So I'm going to guess most people are going to stop at the first one, equals 0, or maybe they might like it to be in standard form, so you might move the constant to the other side. I really don't say like you have to solve for y equals mx plus b, because that opens you up to making more mistakes, right? Does anybody have any questions about that? Alright, so we've got about a little under 15 minutes. When you think back to like this stuff is not on your homework. Only the determinants from the beginning is on your homework. You should get a nice chunk of this done in a little over 10 minutes. So please get out the textbook at the pods. Please start work on the determinants. If you need to work on your quiz correction row echelon form or ask a question, please do that. And I will come around and take a peek at your homework assignment from last night as well. One moment.